So we've been talking a lot about green assets, green water sensitive urban design assets. Bit of shift in pace now over to Dale, looking more over the grey WSUD assets. And he's had a lot of experience in the performance of permeable and porous pavements. And they're obviously becoming increasingly popular. South Australia's uptake rate is quite high, I'm told, relative to other states, but we also want to be making sure that we're maintaining them again to make sure these assets are performing the way that they're intended. So I'll welcome Dale.
Hello everyone, some great sessions and lots of interesting topics. I feel like jumping in and saying, I'd like to say something there, but the speaker's been covering it really well, and some really good to actually hear from some contractors out there doing the work, fixing these assets and learning from that. A few years ago, the WSUD industry was sort of in a space where there was almost no one actually out there doing it. So it's great to see that we're now talking about what comes out of doing it and the positive outcomes we can get, rather than, as Rob said at the start, that there's a lot of negativity about WSUD and maintenance, and that's been the case for a while. So it's good to see that turning around. Following that theme a little bit, I thought it might be good to talk about permeable paving and thinking about, how badly can it really go wrong? What's the worst that can happen? And what I'd like to talk about today is some testing we did, which was actually a number of years ago, but it'd be great to go back and have a look and see how they're doing now. But really just trying to unpack and understand, how are these systems working? Where are they failing? What do we need to be doing differently? And trying to really understand what's actually going on. So I'll kick off. So we understand probably the biggest challenge we have in our cities is this problem of permeability, that we've got high levels of imperviousness, we've got buildings, we've got roads, we've got all this infrastructure we're putting in, more concrete, as Rob was saying, and we're lacking in vegetation and permeable space. We've done some assessments in Melbourne, and we're talking about 35% is permeable in the city of Port Phillip. It's maybe up to about 45% when we push out to the middle suburbs and go out a bit further. But however you look at it, permeability is pretty low, and it's decreasing. And if anything, I'd say some of our new suburbs have probably got even worse permeability than some of our old existing ones. So we know we've got a problem, and we know what the consequences are. We get anywhere between 3 and 7 times as much runoff off an impervious area than we get off a permeable area that's vegetated and has plants in it. So as a rough rule of thumb, you might get 5 times as much water to deal with. That means more water in the waterway more often. It means more flooding. It means that we're losing all the critters in our streams and our waterways downstream. They are literally getting washed away. A lot of the native creatures, they can only swim so fast, and literally the flow rates in our waterways are so high these days that most of the creatures simply can't survive, and they disappear, and we get left with essentially the cockroaches of the aquatic world are the only things that hang on and survive in those conditions. And we see the same 5, 10, 20 species in every one of our urban waterways wherever you go, because that's pretty much all that survives. We see low soil moisture, we see more flooding problems, all these issues. So City of Melbourne is trying to slow down the degradation and even maybe turn it around. They're trying to increase permeability. Obviously, the gold standard is to do vegetation, put in more trees, green roofs, plants, rain gardens wherever we can. But we can only do so much in terms of taking up parking and roads. So where you can't do a vegetated solution, we're coming back to say, can we at least make our roads more permeable so that we can get some water into the ground? And permeable pavement kind of offers the best of both worlds. It works as a pavement, you can park your car on it, but it can also infiltrate the water. So maybe it's the best option where we can't offer some of these other alternatives. So quick, what's permeable pavement? Basically, it's just a permeable pavement surface, which could be pavers, it could be asphalt, it could be concrete. Usually sits on a base of sand or aggregate, and then you'll have a base course sitting underneath that, which is usually gravel or similar, and then that will sit on the underlying in situ soils. Notionally, there's a detention component which is above the under drainage, which the water will flow in, maybe held for a little bit of time, and then will fairly freely flow out. And then there's retention below that under drainage outlet where the water is actually trapped in the system and forced to infiltrate into the underlying and surrounding soils. And that's a really important thing to remember, because we see a lot of permeable pavements designed without that elevated under drainage. And honestly, in my view, they're probably actually not doing a whole lot. You get a bit of incidental opportunistic infiltration, but most of the water just goes straight out the drain on the other side. Some permeable paving in the city of Melbourne, which was our test study for a couple of projects we did with them. This is permeable block pavers. So anyone that says you can't do WSUD, it's too hard, it's too dense, this is Collins Street in the city centre of Melbourne. It's about as dense, built up, high-rise skyscrapers, heritage buildings all around it. It's about as hard to get WSUD in here as you can get. They can still manage some permeable block pavers in here. This is Eads Place, so another one. This is a few years old. This is probably one of their early ones that they put in. So it's up in North Melbourne, and they've essentially just excavated out car parking, laid in the base course, and then permeable pavement over permeable asphalt, I should say, over the top of it. You can see on the right side the permeable asphalt there. Under construction, you can see them laying it down. So as I said before, you've got your pavers or your asphalt on top, bit of a base, and then your base course underneath. Question is, do they work? There were a few people at City of Melbourne that were saying, well, are they actually working? We think they're probably blocked up, they're probably not working. Some people say, yeah, they'll be fine, they'll be all right. Other people say they'll just clog up and fail. What's the answer? So we went out and we did some testing to try and answer those questions. This is one of our former employees, Steve, here, demonstrating the testing, and then we've got Tox-Free did the pressure washing and cleaning for us. So basically we did testing, we cleaned the pavements, we came back and we tested again to see what happened, to see if the cleaning actually worked, and then we come back after a period of time to see what happens over time after we've done the cleaning. We looked at 4 different sites. So we did those modular block pavers I showed you in Collins Street. We did some testing of those. We did Eads Place, and then we did another one in Harris Street, which ended up being quite an interesting case study. Beautiful plane trees all along the street. Looks amazing, fantastic canopy. Terrible for permeable pavements. And then we looked at another one, which is Abbotsford Street. Few learnings there too. We use 2 different test methods. One of the things you find when you start getting into this is because permeable pavements are heavily used in the US and Europe, but hardly anyone does them in Australia, there simply are no testing standards. There's nothing, there's no guidance, there's nothing to help you in Australia. So we turned to the American testing standards to get some guidance on how to do some infiltration testing. And they have a standard method, which is essentially a ring. You put the water in, you pour the water in, and you maintain a constant flow rate, and you time it, and you measure how long it takes and how much water you get through your system. We then used a second test method, which uses a wooden frame in a larger space. And the advantage of this is that sometimes you find with a really clogged surface with this test that it's difficult to get a good read on what's going on. So having a bigger surface area means that you get over some of the vagaries of sort of spatial variations. Sometimes you might, you picked an area that's really clogged or really not clogged, you kind of miss the variation of what's going on. A bigger patch means that chances are somewhere and that will be draining a little bit at least, so you get a better read. Ideally, you do the same test and you repeat it over and over, but what we've found is that the ASTM test works best for freely draining pavements that are working pretty well, and the simple infiltration test or SIT test works best for ones that are pretty badly clogged up, because it's easier to get an actual measurement, shall we say. Cleaning, we tried pressure washing, we tried vacuuming, and we tried a combination of vacuuming and pressure washing together to see what would work best. As I said before, we had Tox-Free doing it. This is just a standard sucker truck that most of your average contractors will have. Our intention was to see what could be done with existing equipment, not trying to get in anything special that wouldn't be readily accessible and usable by any other council. And then we came back and we retested 4 months, 8 months and 12 months to see what happened to the infiltration rates afterwards. And ideally we'd have pushed this out probably to about 3 years, but we just didn't have the budget and the project to keep going. What do we find? So Testing before cleaning. What we found, the results were mixed. Some of them were doing quite well, and what I'd say is all of them were clogged to some degree. None of them were performing at the manufacturer specifications, which are like 3,000 millimeters an hour, 5,000 millimeters an hour, all these amazingly high levels. And you see the videos where they get the water truck and they pour it over the pavement, and the water disappears. That's kind of you get that initially, but it doesn't stay there very long. So we saw the rates are lower, but look, 200 mil an hour is fine. That's way more than the average 10-year storm, even if you allow for 4 times the catchment over it, and the catchment being 4 times the size of the pavement. You know, that's 40 or 50 mil an hour storm that can infiltrate. That's plenty. That's good enough. The other end of the spectrum, Harris Street, we got out there, we set up our system, we did our testing, and we got nothing. And I sat there thinking, I'm a silly goose. I've gone out and done infiltration testing on a standard pavement, and it doesn't actually infiltrate because the water didn't go anywhere. So here I was, we come back to the office thinking I'm a silly goose, and we worked out that sure enough, we had tested the right spot. We went and did the cleaning, and sure enough, we were in the right spot, but we were getting no infiltration at all in this area. It was completely clogged. So we cleaned it, looks nice, much better than it was. You can see the difference from left to right, pre-cleaning and then post-cleaning. So visually, looks like we're making progress. What we weren't sure of is whether all the stuff clogs up on the surface and we can actually just blast that off and clean it, or whether it penetrates right through and the whole thing gets blocked up with sediment, and just cleaning off the surface is going to do nothing. So this was an interesting test. And sure enough, cleaning works. Coming through on pressure washing, we found that even the high infiltration rates, were able to increase them significantly. And Harris Street, where I thought I was a silly goose and were infiltration testing the real road, not the permeable road, turns out it was actually a permeable pavement, and we were able to get it back to something like 5,000 millimeters an hour just by pressure washing and spraying the surface of it. So that gave us a bit of confidence that cleaning certainly can work. The question for us then is how sustained are those outcomes? But before I get into that, I thought it just worth touching on a few learnings that we got from the cleaning. Couple of things, really simple stuff. Get your permits in advance. For some reason, it takes about a week just to get a parking permit arranged with the council, even when you've got a council officer doing it. So make sure you've got all your bureaucracy sorted out. It's important to think about protective measures, pedestrians, cars, all that sort of thing. Make sure you've got guards in place. Try and keep the high pressure spray so you're not spraying gravel into the cars around you. You need to have that in place. The other thing about parking is we found that even though we had permits in place, even though the entire area was blocked off as warning no standing, from 8 a.m. that day, we found that people had their cars parked there from the day before, that people just ignored the signs and come and park there anyway. And even in this video, you can see the cars up there. This whole area has been marked as no standing on that day, but we've still got at least 3 cars parked in these areas. So you've got to allow yourself a way bigger buffer of time than you think you need to just get in and do the cleaning. Some other stuff, just get in and sweep. It's probably underrated, just getting in and sweeping. You can get rid of a lot of the loose material. It's a lot easier than trying to pressure wash leaves and bits and bobs. There's probably a case for doing our street sweeping a bit more where you've got permeable pavements. We also found it wasn't simply a matter of just getting out there with your gurney and blasting the asphalt and away you go. We found that you had to really calibrate your pressure. You didn't want to hit it so hard that you were blasting gravel off, but you had to hit it pretty hard. And if you just went over with a soft wash, or you just went over it really quickly, we found that was quite ineffective. And you had to basically consciously spray and keep the spray in one spot and gradually move evenly back and forth over the pavement and keep it there for 30 seconds to a minute per square metre to make sure that you got it clean. So it wasn't as simple as just get out there with a gun and spray. Lastly, there's a whole heap of pollution here. As Rob said, all this stuff is washing into our waterways. If all we do is hose it down into the nearest grate, then we're not actually solving anything here. We're just washing the pollution back into our waterways. So it's really important when we do this that you make sure you brief and your contractor specs, make sure that they've got some vacuum pipes or suction materials or whatever they need to make sure you're picking up all the material that's washed off and collecting all that wastewater. So much for cleaning. We then went back and tested again. So as I said, we did 4, 8, 12 months to look at what happened to those infiltration rates. And sure enough, what we see is that they actually drop off really rapidly. Those initial wonderful looking rates we get drop exponentially, and then it kind of flattens out and asymptotes out. And it's worth saying, many years ago, I did my PhD on infiltration. We looked at a whole bunch of systems for infiltration, and this pretty much exactly mirrors the clogging and degradation rates we see on every other type of infiltration system, be it a trench, a basin, a rain garden, whatever else. It flattens out drops off exponentially and then flattens out to an asymptote. The tricky question is whether it levels off and stays somewhere or it just keeps going down to zero. And I don't think that's necessarily clear cut. I think you can probably get either depending on the situation. In terms of clogging mechanisms, there are a range. We saw incremental slow clogging occurring, where it seems to occur due to broad sediment distribution across the area and a gradual drop of infiltration across the board, across the pavement. We also saw patchy clogging, where we could drop our tester in one point and we'd come up with almost nothing in terms of an infiltration rate. We pick a different spot that looked a bit better and we get quite a high infiltration rate. And what that is indicating is that you're getting patches of sediment accumulating that are really blocking up those areas, particularly areas of high hydraulic loading. So right next to your garden beds, right next to the road where the water's washing off, you'd see that clogging up, and then further into the middle of the asset, you'd see that it was still quite clear and the water was still infiltrating freely. So you get this sort of spatial distribution of the infiltration rates and the clogging, which means it's really important to test these systems in more than one spot if you want to get a decent measure of what's going on. Major contributors were the granitic sand pouring off the garden beds and the tree pits around it. Also organic matter. Plain trees and permeable pavements are really not a great combination. There's huge amounts of not only the leaves, but also the seed pods and the flowers and all the pollen and stuff that comes off them. And that seems to sort of break down and form this fine organic mass that sort of just blocks everything up. So organic clogging can be a big problem as well as just the physical sediment clogging. So I guess to wrap it up, what do we find? Basically, yes, systems were clogged. Some were still actually working quite well. So yes, they were clogged. Was there a problem? Not really. If you left them there, they'd probably work perfectly fine. They'd probably last a few more years. And we'd say that you're probably getting anywhere between 50 and 70% of the intended benefit, if not more. On the flip side, some was literally not functioning. You know, Harris Street, there was no water at all going into that system, nothing getting to those trees to passively water them. So they pretty much completely failed. Worth saying that was after, I think it was 7 or 8 years of operation that we saw that failure. So it took quite some time for that to build up. So first thing is, yes, you have to clean your permeable pavements. I'm sorry for all those people that have been telling everyone that you don't have to, or would like to think that you don't have to. For those people that think that they're less hard work than rain gardens, not necessarily, and worth keeping in mind that usually they're a much bigger size relative to catchments. So on balance, you might end up doing a similar amount of work and similar cost to your rain gardens potentially. The cleaning worked. So vacuuming failed spectacularly. Not only was it terrible from a OH&S perspective, but it actually failed to clean the asset. That said, we've read research from people overseas with different equipment, different vacuuming systems where they've reported quite good success. So I wouldn't write vacuuming off, but in our case, we found it wasn't working for us, but the pressure washing was. My thinking is that probably vacuuming to get rid of the worst of stuff, and then pressure washing is probably the best of both worlds, because we don't really want to run the risk of driving material too much deeper into the pavements if we can avoid it. So clearly it works. Clearly it improves functionality. Yes, your infiltration rates will drop exponentially. So your initial infiltration rate honestly really means nothing in a permeable pavement. What is more important, however, is how frequently you come back and clean it. And the idea is to try and keep that infiltration rate in a sweet spot, you know, anywhere between 50 to 100 mil an hour up to maybe 500 mil an hour. I'd be perfectly happy with that. It doesn't need to be 5,000 millimeters an hour, but if it's down to 2, then it's probably time to do something about it. So really, I mean, what's the worst that could happen? What could really go wrong with permeable pavements? You know, a sinkhole is going to open up and the road's going to collapse, or, you know, the footpath is going to fall in. Probably not. Probably we're just going to spend a bit more money than we would have on a road, and we're not going to get any infiltration out of it if we're not prepared to do the maintenance, which from an environmental point of view is a tragedy. From a constructing a road point of view, well, it's still working as a road, so perhaps we should be a little bit less afraid of it and do a little bit more of these. So a couple other comments. Yes, we can use them with confidence. We need to commit to cleaning. We, after the City of Melbourne, were recommending probably cleaning 1 to 2 years. I mean, I'd say realistically, you'd probably say you need to get out there and do them every 2 to 5 years. In an ideal world, you might do them every 1 or 2 years. You need to sweep regularly, and that's not just the pavement. We need to be sweeping the catchments that we're building these in more regularly and actually having some efforts to pick up the sediment and litter. We also need to look closely at upstream garden beds. You know, we've got mulch and granitic sand washing off things into the road. We should be dealing with that, not just continuing to chuck more on it. We should expect to be out doing inspections every year or 2 to make sure they're still working, and cleaning maybe every 1 to 4 or 1 to 5 years. And finally, I think it's worth saying that there's been a renewed interest in the last few years in actually doing monitoring of WSUD assets, actually testing them to see what's happening. And really, we need to be doing the sort of work that Rob's doing, where we're out there actively maintaining them and looking at what they're doing. We need to be testing them and actually running scientific tests to measure infiltration rates to say what's actually happening here. We need to be putting in loggers and monitoring systems to monitor flow rates and water levels, to really understand how their systems are working and not working, so that we can make sure they're all functioning much better and we're getting the benefits out of them that we're promising when we spend millions of dollars building them. So that's it from me, except for a couple of final design considerations. So firstly, the rate of clogging is dependent on your upstream catchment. So really, ideally, a permeable pavement should be treating the water that falls directly on itself. At most, it should be treating maybe the road surface area as draining onto the car parks next to it. And I'd say absolute worst, you might have a ratio of about 4 or 5 to 1, where, you know, your catchment, say 100 square metres and your pavement's maybe 20 square metres at the absolute worst. But basically think of it this way. If you double the amount of catchment going into the permeable pavement, you're essentially halving the time before you need to come and clean it. That clogging rate will be twice as quick and you'll need to come and clean it twice as often. So think about that carefully when you're building a permeable pavement that's 5 square metres on a 100 square metre catchment. It's not really going to work very well. Think about the upstream sediment. And finally, just because we see this all the time, to me, the real benefits of this system are that they're infiltrating water into the ground to recharge water, and that it's allowing passive irrigation for all the trees around it. If we're not doing vegetation, if we're not actually getting some benefits, I'd sort of say, well, what's the point? Is it really worth spending all this money on these permeable pavements? There's probably better solutions like sticking a rain garden in the corner of your car park or something like that. So let's be thinking about that. And let's get the base of these systems, or the outlets of these systems, elevated to maximise that infiltration, so that we're actually getting the benefits we're aiming for. So thank you. I'll leave it at that. Any questions?
I do have some here from in the chat. Would you mind going back to your image where you've got the 2 testing methods, and you Rob's asked, what's the white ring around the test bowl? Is that just
what's the white ring here?
The putty?
Yeah, that's right. It's putty. It's plumber's putty. When you put those rings on the pavement, you need to make sure that when you pour the water on, it doesn't just all go shooting out the sides. So we just get some plumber's putty from Bunnings, stick it all around. Rob's given me the thumbs up. He's obviously done a few of these. Plumber's putty around the outside, and then that keeps it in place. You still get leakage sometimes, but you just got to be generous with it. We reuse it too, because otherwise you just go through tons of it. Pour your water in, the way you go. Also, you can spend think about $900 buying a proper scientific set of these, or you can spend about $30 and buy a baking tin, and they work pretty well. So
nice. Yeah, we like that improvising. Excellent. Thanks.
And we made the wooden frames ourselves too. So.
Oh, okay. So you really have been quite, handyman out there.
I had to learn a few things to do these. Yeah.
Excellent. So someone's asked, have you published the results? So the results of all this testing, is this in a public document that we could all read?
It's published in a conference paper. There's a couple of reports for City of Melbourne, but we haven't got to doing a journal paper or anything like that. It'd be nice, but we haven't got there. But if anyone's really keen, follow me up and I'll touch base with City of Melbourne. We may be able to share the report. Just have to check if there's any sensitivity at their end.
And the paper, what conference was that from? Is that Stormwater Victoria?
Stormwater Victoria. It was a few years ago, to be honest. I'll send you around the link and you can share it with everyone. Awesome. So it's Permeable Paving. What's the concrete evidence is the title of the paper.
Yeah, I have seen that one.
Yeah.
That's how I found you for this.
I think it's available online, yeah.
Yeah, I think it is.
Yeah.
All right. Okay, excellent. We'll find that and share that. Now, there was another question. Has the maintenance regime subsequently been modified to address the fast clogging location? So do you know if there's a feedback loop, like you did this work and did it change practices at council? Are you aware?
We've given them recommendations. I haven't followed up recently to see where they're at with their maintenance. Rob may even be doing their maintenance for them, possibly. No. Occasional, yeah. What I would say is that it's important to understand your catchment, and if you've got a catchment that's got deciduous trees in it, and especially if you've got plane trees right on top of it, you probably need to maintain it at least twice as often as a catchment that's got nothing. So, for example, each place, there's trees there, but they're not really doing a lot. They're not causing too much trouble. You easily leave that for 2 or 3 years without maintaining it. Harris Street is getting hammered. It's got massive plane trees all over the top of it, and there's huge amounts of just stuff coming onto them. I'd say you could probably clean that once a year, and you'd probably still be flat out keeping up with it. So, yeah. Okay.
Andrew's just asked here, there was sort of a lot of porous asphalt. You did do some permeable paving. Did you test any permeable block pavers? I suppose the ones that have lots of aggregate between, like it's hard to tell. That presumably the one that you're showing there, is that the like 2 to 5 mil aggregate in between each paver?
That's right. There's ones you're looking at here have actually got they've got sand between them, so they are the block pavers. There's two types. There's the block pavers, which are permeable themselves, and then there's the ones with the gaps in between where the water's allowed to go in through the gaps. So there are those types. I think these are solid blocks and just letting the water infiltrate around the edges, which had sand in them. But after we clean them, one of the problems is it does blast all the sand out of the surface. So you do need to come back and bed the sand back in to make sure that they're stable.
All right. So in South Australia, our sort of standard drawings are putting 2 to 7 mil aggregate between the black pavers. Have you had any experience testing or that?
We haven't tested those, but they're probably a little bit more durable to the sand getting blasted out. That said, when we're doing the asphalt, we're finding we're having to attenuate the pressure we're putting on them because we're actually stripping the asphalt off the surface to get enough pressure to get a good clean. So chances are you'll find that you are blowing a bit of your aggregate out, and you do need to come and top it up a bit, I would expect.
Thanks so much, Dale. A bit of myth busting there, which is great. But to me, what that's suggesting is, these things are performing quite well, but they're probably set and forget is like one step at asset management gone too far.
Yeah,
we do have to be a bit more proactive if we want it to perform the way it's intended.